Okay, well, I'm going to start now because it's 3:30, Jack. So this is Dr. Jack Wang. He's from the University of Queensland, and his talk is about BioLab Collective, where he's been establishing an online lab training platform in molecular biosciences. You go well, Jack.
Okay, hello everyone. It's 5:30 p.m. here at Queensland. I don't know what time it is in various parts of the world where you're watching this after the fact, but I'm going to share my screen now, and hopefully you can see what's on my screen. So this is a project that I've been working on at the University of Queensland for about 5 years, and it's really come to a head in the recent few months because, of course, laboratory skills training in a time where many students can't physically enter a laboratory is something that the whole sector is wondering about. And this is the question. Can we learn laboratory skills virtually? And I think for the last however many years the discipline has been around, whether it be microbiology, biochemistry, biomedical sciences, we've all collectively said, no, you cannot learn laboratory skills virtually at all, and we don't trust any students without hands-on lab experience. But as this time drags on, when students don't have the chance to learn lab skills, I think the answer to that question has slowly become, well, which part of lab skills can we actually give them without physically being there? And to answer that question, if we can give them any part of cognition or awareness of the laboratory environment, at the end of the day, you require specialized online resources to do so. It's not just you just go to the lab and take some pictures and it's fine. And we can go all the way from this virtual reality-based system like Labster, or maybe something a little less complex, an augmented reality system. But most of the time, I think universities aren't developing these in-house. These are proprietary, pay subscription, institution-wide license kind of models. If we want to look at what individual instructors can do, it's veering more on the end of videos or animations or quizzes, and together you give them a sense of what's happening in the laboratory environment with the hope that it's just patching things together long enough for when they eventually return to a laboratory environment, they've got some awareness of what they should be expecting when they step foot inside a genetics, a micro or biochem lab for the very first time. And of all the resources I just outlined, whether it be virtual reality, augmented reality, or videos, animations, the type of resource we're focused on has been videos, and there's a few reasons for this. First of which is that if you're doing any kind of course remotely, the expectation nowadays is that you will have a lot of video content, and this number is from 2015, so I'm pretty sure it's an underestimate now, but certainly the vast majority of online course content hosted on any kind of learning management system is video. So if you invest in good quality video resources, that will kind of move with you even if your institution changes learning management systems overnight. But given its value and its real advantage in facilitating learning, video also has quite a few downsides. And the downside, of course, is the length of time required to produce good quality video, and also how you decide which kind of video you'd like to produce. And of course, this is just a small snippet of the types of video presentation styles that are out there. Talking head, the instructor being on screen, picture-in-picture, where you have the slide and the lecturer's or the presenter's head in the corner, kind of like this model, as well as the style made famous by the Khan Academy, writing on some kind of tablet or some kind of notepad and filming that, as well as demonstrations in the lab. There's all of these different formats to choose from, and I'd go to argue that it's not a skill set that's very common in science academia at the very least. So we're kind of, brushing up against the tide and swimming upstream, if you like. And also, we all know what a bad video is when we see it, but it's kind of hard to recreate what we feel is good because there's a creative element to it that really hasn't been pinpointed, certainly in the science sector. And it's kind of like anything creative. Everyone knows a good song when they hear it, but not everyone can write good songs. Which brings me to the theory behind, again, why video is a good vessel for delivering remote content, and the predominant learning theory that we hear again and again is Mayer's multimedia learning theory, and there is a lot of work done in this space that reinforces these findings. But to put it simply, it's essentially multimedia, multimodal sources of stimulus, whether it be visual, graphics, or sound, or music. If you combine multiple sources of stimulus at the same time, that could give the learner the best chance of getting something from that range of stimuli that will facilitate their understanding. And there's a whole bunch of principles here. I'm not going to read through every principle on this slide, but a few. So the first one is, if you have a textbook that is just words, that's probably not quite as interactive as a resource that has both words and pictures, and maybe even the words are read out aloud. And also with video, whatever's in frame, whatever you put on screen, and ideally that thing is moving because it's video, it's not just a static slide, that is all people can focus on, and that will have some inherent implication that it must be important, otherwise why it's on screen. So you can have all this ability to exclude extraneous information, highlight key information, and it's actually a really powerful vessel for delivering good quality information as it relates to learning. Which brings me to the project, the BioLab Collective project. It's actually a project funded by the Australian Council of Deans of Science, and it has two main aims, the first of which is to make a novel library of laboratory videos. And the idea is that if you're teaching across any molecular bioscience program, in Australia, I guess, but really across the globe, and everyone wants to have some lab videos, there are some foundational skills that we all teach, and it doesn't make sense, to my mind, for all of us to make the same video again and again. Like pipetting, for example, maybe you make that video once and you do it really well and everyone can share it, and we can spend our resources making other learning resources that are maybe a little bit more advanced, a little bit more institutionally specific. The other second part of it is this skills training framework idea, in that when you learn through laboratory pracs, a lot of the heavy lifting is being done by the laboratory itself, just because it's a new environment. There's a lot of contextual clues about what you should do, what you shouldn't do, a lot of biohazard symbols, a lot of people frowning on you when you accidentally set something on fire. But if you're watching videos and you're looking at an online lab environment, all of those context clues just go out the window. You have no idea. So the common mistakes and misconceptions that you might make need to be made much more explicit. And I think once we remove the lab environment and make this very explicit, when you bring back the lab environment for these students learning lab skills, I think that's only a good thing for us to make our lab classes more clear and make the learning objectives more clear as well through this skills training framework, which we are forming by talking to a lot of academics across Australia who teach molecular biosciences. We've talked to people across 10 institutions up to this point, and I'll come back to this later on today. And the first aim, of course, is to make videos. And I guess you might be thinking, well, Jack, what gives you the right to say you know how to make videos? And I'm not claiming I know how to make videos, but we have done a fair bit of work on this. We've been making videos for about 5 years. We have a YouTube channel, BioLab Collective, and this predated COVID. So it wasn't quite as ad hoc as many video efforts out there in the sector. And part of this is we did an initial scoping study on students. We surveyed as close to 100 students as we can, so about 80 students. And we asked them, these are all the video learning styles that are available. Do you have a preference? And we asked them to rank each video style in terms of how much it facilitates their learning on a scale to 1 to 5, where 5 is it makes my learning gains the maximum amount of productivity. And I don't know if you can tell by this graph, but we can group students, and we tried to group students based on all sorts of social, emotional, cognitive scales. And in this particular instance, it's active students in white and passive students in black. But it doesn't matter how we divide the students up. There's not too much difference in which video format any type of student prefers. And this is the only type that showed any difference. So active students appear to prefer talking head style videos where you can see the instructor more than passive students, but it's a very modest increase in preference and their perception of its learning gains. It's very, very modest. And what this told us is that, well, sadly, there's no one single presentation style that all students prefer. So we can't just all just do Khan Academy stuff and it's going to be great. Really, this informed us that we have to have every trick up our sleeve as it relates to making videos and make as many different types of scenes. And every time we switch to a different kind of presentation style, this tells the students, hey, something else is happening. And this aligns with all those principles I talked about, where it's signaling something's important, excluding extraneous information, and it aligns with all those good design principles from Meyer's multimedia learning theory. And what this is ultimately trying to do is replicate part of the in-class experience. And as all of us are experienced instructors, we know that this graph, which is a very sad graph, but it shows the state of affairs for any kind of public speaking, you lose people over time. And in person, hopefully students will give you half an hour's worth of their attention. And at that point, you can see them nodding off because you can gauge what's happening in the room. And we have all sorts of tricks, right? We can ask a very hard question, ask people to stand up, or show some kind of shopping graphic or graph, or ask student volunteers to do something, or give out candy or golden tickets. We can do all sorts of things. But in this environment where students are watching these videos online by themselves in a different time zone, we really can't use those same set of tricks, right? And this audience retention curve is going to keep dropping. And this is from, so this gray cloud-looking diagram, that's essentially the retention drop-off for every single video on YouTube. So we're not alone. Every video online has a whittling retention, and it's even more accelerated than in person. So you can see this is like a 6-minute video. You can still see dropping attention. In person, maybe the attention spans a little bit more. And the trick that we have is trying to switch between at least 3 sets of scenes, right? So if it's a video, A, keep it shorter if you can, and B, have a few different scenes, a few different presentation styles to switch between. And every time you switch, that's a subconscious cue that, hey, something different's happening on screen. Something more relevant might be worthy of your attention. And the other design principle is that we don't make videos that are about a whole class, because every institution will teach laboratory skills slightly differently or embedded within a different learning sequence. So every video is about 5 to 10 minutes and is focused on one specific laboratory skill, and that maximizes the evergreen nature of these videos so that it can be reused across multiple contexts. This seems a little abstract, so I'm going to try to play you a video clip from it now. It only goes for 1 minute, and I'm almost certain that it won't play very well, but let's give this a go. I'm going to try to share a clip from a video. So I'm going to try this again, and there should be sound, so if you can't hear sound, it's not working very well, but it might lag. So let's give this a go. I'm going to share it now and play it.
Working well, Jack?
Biological organisms are constantly interacting with the environment around them. Aseptic technique is how scientists prevent contamination and the spread of pathogens. It will cover its use in isolating microbes, transferring biological liquids, and how to avoid some common mistakes. Think about aseptic technique as moving a sample from point A to point B without introducing any contaminants into the mix. When pouring nutrient media from one bottle to another, or isolating a pathogen onto plates, contamination can come from the bottles, the plates, the surrounding airflow, the bench surface, or simply your hands. Aseptic technique is all about minimizing exposure to as many sources of contamination as possible.
All right, so hopefully that worked okay. I think it did. I'm going to share my slides once again. But the first thing you'll notice when you see that clip is it's actually really fast-paced, right? And it's probably faster than I would personally like, and maybe faster than how you learn. That was the introduction part of the video, so it was designed to be pretty fast-paced. It does slow down, but the reason I selected that is we've done some analysis and showed that pacing really does affect retention. And how we did it was we made 2 batches of videos. The first batch is what we call season 1, and this is where the pacing is actually much slower, and we can quantify that in a few different ways. So every time it cuts to a scene that looks completely different, so if it's me on screen to the handwriting, that is 1 scene transition. And if you cut from the writing to a lab demonstration, that's yet another scene transition. And we made, I think, close to 10 videos in season 1, and we quantified that we weren't doing that much movement between these 3 different types of scenes, and it's about 6 scene transitions over a period of 5 minutes. So roughly every minute, it would move to a different type of scene. And then we measured the audience retention, depending on the type of scene. And you can see by this graph that in the season 1 videos, which were much slower in pace, there was fluctuating audience retention. It would go up, it would go down, and that's not what you want. You want it to stay pretty steady over time, because every time it drops, they might never come back. Right? They'll just click out. There's a million other things to do on YouTube, on their computer. They'll just drop out. And that clip you just saw before wasn't from season 1. That was from season 2, where we can quantify it again. It was much quicker in pace, not quite as quick as that segment all the time, but it's much quicker overall. Again, every time you cut from one type of scene to another type of scene, that's 1 scene transition. And season 2 videos were about the same in length, between 5 to 10 minutes, and it was closer to 30 scene transitions per video. And when you imbue that kind of pacing, that kind of multimodal presentation style, you can see here that the audience retention is kept at a consistent 80% or greater throughout the whole video. So this really informs us that even though that quick pacing won't work in every part of the video, cutting between types of scenes really helps rejig the student's attention and focus them on the next thing that's coming up. And we made a number of lab videos, but I thought I'd just have a brief interlude here. I think I do have time. I think I have 5 minutes left. And this is the question. That design principle, which we found out through lab videos well before COVID, can we take anything away from those learning analytics to improve the asynchronous experience in other kinds of videos we make? And the number one target for this are our lectures. So of course, in 2020, we couldn't really give in-person lectures to the same number of students, and they have lecture recordings. So in 2019, we have lecture recordings, and these weren't edited in any way. These are just automated recordings. They turn on and turn off after 50 minutes, and the students couldn't see the instructor. So it's not aligning with the design principles I just talked about. It's all slides. There's no cutting really between different presentation styles, and it's quite a long recording. But we took those design principles in the lab videos in 2020, and we cut up our lectures and edited them down so that there's a intersplicing between presenters as well as the slide, as well as the time stamping. So when we edit it, we can actually add timestamps to every slide so that students, when they're watching it, can scrub between concepts really quickly. And the same number of lectures we were able to edit down to about 30 minutes each, as opposed to 50 minutes each. And these weren't scripted. So this is just when we gave the same material, which took about an hour in 2019. If you go through and edit it down and cut out the pauses, it turns out that just by virtue of doing that editing process, you can almost halve the viewing length of these kinds of videos. And again, I'm going to try and show you a clip from the lecture because I'm getting close to the end. So I'm going to give this a go. A sample from the lectures that I edited. Let's see how this goes. Okay, hello everyone. Welcome to Micro 2000, Microbiology and Immunology. My name is Jack Wei, and I'm the course coordinator this semester. This is still quite an unusual setting that we find ourselves in, and today, in this first lecture, which you will be watching online, I want to go through the key aspects of the course, what you should expect in terms of the assessment and the structure week to week of what we'll be going through, as well as how the semester will look as we progress. We have a few learning objectives in today's lecture. We want to first of all explain the course structure and the assessment details. And once we've gone through that and you've lined up all the assessment in your calendars and everything is locked in, then we'll go through some concepts and content as it relates to microorganisms. All right, so you get a sense of that, and I'm conscious of time. I've got 2 minutes left, so I'm going to go through the main concepts emerging from that experience. And this is just to show you that we're using the same principles, right? So we're cutting between different views of the lecture, back to the slide, and the slide can incorporate picture-in-picture with my face in the corner. And this really gives flexibility in editing and really makes the videos the students access to be very compatible with asynchronous delivery watching after the fact. All right. And this does have an effect on student engagement because we can see that in red in 2020, they're watching each video, each lecture video in 2020, roughly twice as much as they are in 2019. And also they're watching closer to 80% of each video in 2020, as opposed to in 2019. They're watching only about 40% on average of those videos that you can see there. All right. So this is just some data to show you that this format really works. Now, we have established an existing repository of 12 laboratory skills videos, and we're still adding to that. We're hoping to add another 10 before the end of this year. And these are all designed to be freely accessible, and there's a link before I finish. You can search for it, but if you Google BioLab Collective, it'll take you to this page with all these lab videos, and you can freely use them without any, if you want to cite us, you can, but as long as you use the videos and they're useful in your context, that's more important. But I want to finish off by talking about this second aim, which is the work that we've been doing in talking to molecular bioscience academics across Australia. And what we've done is we've circulated this really big lab skill inventory, which has been previously published in different biological science journals. And we've asked the instructors which of these skills they think would benefit from a video and what kind of videos would be most useful to them. And all these panels down the bottom appear to be the things that they're saying are the most useful. And it's quite interesting. I'll highlight a couple of themes. We thought that every skill would be equally important, but it turns out that academics want either really basic introductory skills or really advanced experiments with very complex requirements, because either they don't have the setup in their institution or they don't have the time to run like a full-on fluorescent staining experiment on embryos in their own context. So it was quite interesting. I thought we'd get more of the middle ground, but it's bifurcated, either really basic skills like pipetting or really advanced complex skills with really difficult reagents. And also we've got a few design elements. And I guess the last thing I want to focus on is that these videos aren't designed to replace the videos you make in your own institutional context. They're just designed to be a conversation starter. And we're aiming to get a lot of skills as opposed to going to every skill in depth. Now, I think I'm just out of time, so I've finished on a couple of thoughts. So firstly, how do you find these videos? You can find these videos on my website, jackwayne.com.au. Or you can Google BioLab Collective. You can go on and all the videos are available on YouTube. And lastly, all that's left is for me to thank my research staff, Azrif, Amy, and Thyssen, as well as the funding that I received from my institution, as well as the Australian Council for Deans of Science. Thank you for everyone coming along, and hopefully we can make contact with those watching asynchronously as well. Thank you.
You know, that was awesome. That's the best talk we've heard over the last 2 days.
Really good, Jack.
Oh no, thank you.
Doubt. What did you think, Jerry?
There we go. Yeah, no, that was fantastic from start to finish.
What?
I mean, I was jealous of the microphone from the off.
Yeah.
I think it's the videos. Yeah, the videos is one thing, but I just think the theory behind what you've done, you've really identified a need. And I know there's kind of questions there in the chat, but I guess that becomes the question now, doesn't it? When you're producing fantastic videos like that, do we need to reimagine what the lab experience becomes? Because obviously you have the motor skills, and your aseptic technique was very good, by the way.
Oh, thank you.
But how do we complement these? Because it's a fantastic resource to have. So I'm just wondering down the line, do we reimagine what the lab experience becomes? Because we can train people in lab skills, right? But the real importance is the concepts and the understanding behind what they're doing, which is what you're providing in effect. So yeah, I think it's going forward. I think it's certainly going to become a major part of how we train people. We will still need the motor skills, and that's the question then, is how you integrate the two. But I thought it was fantastic from start to finish.
It was.
Oh, thank you so much, Jerry. Yeah. Jerry, where are you from?
I am from Cork, which is in the southwest tip of Ireland. Yeah. So we do a lot of, yeah. So very, very, it is, except it is very wet at the moment and very hard to see out.
Well, outside our windows is just like Jerry's, sunshine, more sunshine.
Yeah.
And too much sunshine.
Yeah. We'll try not to send this weather your way.
Yeah. Jack, I had a question about the videos were so professional. Do you have on-site sort of audio visual support and professional videographers to help you do that, or?
Yeah, okay. So I see questions in the chat as well, so I'll try and get to everything. So no is the answer to professional videographers.
Oh, show off.
I had to learn everything from scratch. Right.
Wow.
So this is, and that's not my background. So it's a very steep learning curve, which is why I think the ad hoc approach during COVID is really unfair on everyone. And institutions have to be very strategic in training people ahead of time, you know, and I'm not sure that's happening across every context. But the other thing is that it's kind of like a personal preference for making it look a certain way. I think it matters, but that's not to say lower production quality means it's not as good of a learning resource. And I don't want this to replace people's motivation to make their own videos in their own context, because students I found really value that, seeing their instructors getting some skin in the game. But if it's pipetting and you want it to be as clear as possible, and it's really, honestly, pipetting is really boring, right? So if you didn't have to make it yourself, and we can make it look really pretty, and that's kind of just a stand-in, then that frees you up to really be more advanced in your pedagogical design for the other stuff that you make, right? And Jerry, to answer your question about how we reimagine labs, I think there's an argument to be made for more simulations, and these videos are still interacting. Not that interactive. So we do have sections where we say, oh, watch the next 30 seconds and spot all the mistakes. And it's very easy with aseptic technique, right? There's just mistakes aplenty, putting tips on the bench and, you know, accidentally scraping your elbow against things. So we can make that kind of interactive nature and couple with quiz questions. But I think even before COVID, when students had in-class prac experiences, most of them still didn't understand the theory behind it, right? So it's like you give and take. And often if you have a lab partner that's really keen, you just kind of sit back and not do anything. So I think we can learn a lot from this experience and make the in-person classes richer as well. Yeah.
See, I mean, we did our own videos for labs last year to replace things, but our approach was to be really stupid. That's why I asked you about, what about amusing, making things amusing. That was, well, you can tell by just meeting me, right? That was my main game. So I dressed up in a wig and I pretended I was a stupid student. And then I had the demonstrators like instruct me and I'd make all these biffo mistakes.
Well, that's great.
And the students loved it. Whether they learned anything.
That's about visualization. And the thing about making videos, like your own videos, maybe not videos designed to share widely, but like you have to have fun making them.
Dropping out a little bit.
Am I dropping out a bit?
Shame.
Sorry, can you still hear me? Okay. Am I coming back? No,
everyone's frozen.
Everyone's frozen.
Oh, Jerry's gone for another session. That's why he froze.
Okay. Can you still hear me? I'm back on. Yeah, okay. So making resources is so time consuming, and making videos, as you know, just takes a lot of extra skills. You have to have fun making it. You have to like make it for yourself first, Otherwise, there's not enough motivation in the world to look at footage of yourself for hours and hours and listen to it. Like you have to like doing it, right? You have to enjoy doing it. Otherwise, there's other industries that aren't so demanding. Yeah.
No, that's true. That's awesome. Really great.